So as we've seen, solving a system of equations by using an augmented matrix is really easy. It only takes the amount of time to put it into the calculator and then lickety-split it gives us the answer. So let's see what could possibly go wrong whenever we enter this in. So here's a system of equations. Let's assume I put it into a matrix, augmented matrix, like so, and I do the row reduce echelon form on it, and this is what I get for an answer. Look down here at the bottom row. It hits 0, 0, 0, 0, which is unexpected. It's a true statement because it's basically saying 0 is equal to 0. But right up above it, I've got 0, 0, 0, 1. Now that is a contradiction because what it's saying is 0x plus 0y plus 0z is equal to 1. In other words, 0 is equal to 1, which just doesn't happen. And if I get a contradiction like this, this means that the original system of equations has no solution. What that means is that it's possible that maybe these things represent planes and all three planes are parallel to each other and they never intersect, so there's no point intersection. Okay. Maybe I have a system of equations that's going to give me infinitely many solutions. Let's see what that looks like. So entering in this system of equations in an augmented matrix and performing the row reduce echelon form on it, this is what I get. Now, at the bottom row, I get 0, 0, 0, 0. And that's okay. That's an identity. It's basically saying, again, 0 is equal to 0. And now on the top of the middle equation, I don't have a contradiction. I have y minus 1/3 z equals 5/3. What this means is I'm going to have infinitely many solutions. Now you don't stop here. The way that we like to write our answer whenever you have a system of equations that gives you infinitely many solutions is as a generic ordered triple in terms of whatever your favorite variable is, like k, for example. So that's what we're going to do here. So we're going to take that middle equation right there and rewrite it in terms of its actual variables, y minus 1/3 z equals 5/3, and pick one of them, either the y or the z, to be equal to your favorite variable, k. So let y equal to k. You'll see why in just a second why I chose y and not z. Now substitute that in there, and now we're going to solve this thing for z. To make it a little simpler, I want to get rid of all the fractions. Get rid of all the fractions by multiplying everything by the least common denominator, which is going to be 3. So I'm going to get 3k minus z equals 5. And now solve that for z by just adding the z to the right and subtracting the 5. Now I've got z in terms of k, and I have y in terms of k. So the last thing that I got to do is get x in terms of k, and that'll be from the top equation. Now before I move on, let me show you what would have happened if I had chosen z to equal to k. So if that's the case, pull up the pen here, I would have y minus 1/3 of k is equal to, hi baby Rowan, 5/3. And now whenever I go to solve this for y, I'd add over the 1/3 k, and then I have a fractional answer for y. 1/3 k plus 5/3. Now there's nothing wrong with fractions, it's just that this is messier than it needs to be. Sometimes you don't have a choice. Sometimes neither one of the choices is going to eliminate all the fractions. But in this case, we could eliminate the fractions. Okay, so now finally let's find x in terms of k by taking that top equation and substituting in the two things that we already know. Well, the one thing, because there's just a z. The z was 3k minus 5. Get rid of all the fractions again by multiplying everything by 3. Okay, and now we're going to solve this thing for x. Distribute the negative sign, get everything on one side except for the x's, and then divide by 3. And now we have our generic ordered triple. This thing represents 100% of all the solutions for this system of equations. In order to find one of the possibilities, you just pick whatever you want for k and substitute it in. Like, for example, k equals 0. Then 0 minus 11 is a negative 11, comma 0, and 3 times 0 minus 5 is negative 5. So here's one of the points that would work in all three of these equations.